Hey Precalculus, so today we're working on double angle formulas, and we derived these in class, but for right now I'm just going to give them to you. So sine of 2x equals 2 cosine x sine x, or 2 sine x cosine x, whatever order you want to go in. Cosine of 2x equals cosine squared x minus sine squared x. These were the two that we talked about in class today. And then there's actually a couple of variations on cosine of 2x if I do a little substitution using cosine squared x plus sine squared x equals 1, our Pythagorean identity. If I get sine squared x by itself, I would say that cosine, I'll get cosine by itself. Cosine squared equals 1 minus sine squared. So if I were to sub 1 minus sine squared in for cosine squared, I would get 1 minus 2 sine squared x, because here I would have 1 minus sine squared, and if I take another way, I have 1 minus 2 sine squared. Or I can do the same thing if I get sine squared by itself. We know sine squared of x equals 1 minus cosine squared. So if I subbed that in for sine squared, I would have a minus 1 and a minus a negative cosine, which would make a positive. So I would have 2 cosine squared x, and then I would have minus 1. So 3 versions of the cosine of 2x formula. I expect you to have the first one memorized, this guy here, and this guy memorized. If you know the other two, great, but you should be able to get them fairly easy from this with your Pythagorean identity. So just these two are the two you need memorized. And then tangent of 2x, I am going to stick with teaching you guys that tangent is just sine over cosine. And I'm not going to have you memorize anything else other than tangent is sine over cosine. Alright, so then using these formulas, today in class we looked at problems like the one I'm going to show you in example 1. So to start with, it's really important that based on the given information, you draw a triangle and you draw it in the right quadrant. And that takes a little bit of work to figure out. So just going to say cosine of x, because I know secant and cosine are reciprocals, is equal to negative 2/3, the reciprocal of negative 3 over 2. And then if tangent is less than 0, that means tangent is negative. And so that tells me that sine over cosine is negative. I already know that cosine is a negative number. And so if something over a negative equals a negative, then that tells me that sine has to be positive. Okay. So I have to use deduction to figure out whether sine is a plus or a minus. Now the reason I care is if I'm thinking about the unit circle, or thinking about my quadrants, right? In this first quadrant, in quadrant 1, I have gone over and up, so it's plus plus. In quadrant 2, I've gone back and up, so back is negative, up is positive. In quadrant 3, I've gone back and down. And in quadrant 4, I've gone forward and down. Since I know that my xy coordinate is cosine sine, sine being positive tells me that I've got to go up, so I'm either going to be in quadrant 1 or 2. And cosine being negative tells me that I had to go back, so either quadrant 2 or 3. So since cosine is negative and sine is positive, that means I've gone back and up, negative, positive. So that means my triangle that I'm going to draw is in quadrant 2. Okay. Now, based on my triangle, now that I've got it drawn, by the way, that is the most important part of these problems, and it's the place that probably is going to trip you up the most. Then I look at what's given. I know cosine is negative 2/3. So cosine is my adjacent over my hypotenuse. So my adjacent side is 2, my hypotenuse is 3. And since I've gone back, I know that the negative goes with the 2, negative 2 over 3. Now I can use Pythagorean theorem to find the height of this triangle. So I've got negative 2 squared plus b squared equals 3 squared. 4 plus b squared equals 9. So b squared equals 5, which means b equals root 5. Okay. And now that I have my triangle filled out, I can find the sine of 2x, cosine of 2x, and tangent of 2x using those formulas that we talked about above. So if I want to find the sine of 2x, that equals 2 cosine x sine x. cosine of x is given to us basically in the formula, so I've got, or in the problem, negative 2/3. Sine of x, we can use our triangle to find. Sine is opposite over hypotenuse, so root 5 over 3. So when I multiply fractions, I go top times top times top. So 2 times 2 is 4, so that's a negative 4 root 5. Over bottom times bottom, 1 times 3 is 9. So there's my answer for sine of 2x. For cosine of 2x, I do the same thing, I just use the cosine formula. So I'm going to go up here to cosine squared minus sine squared. So let's see, cosine squared is just whatever cosine is, so negative 2/3, and then I square it. Sine squared is whatever sine is, and I square it. So I get, let's see, negative 2 squared, a negative times a negative is a positive, so I get 4/9 there, because I square the top and square the bottom. The square of root 5 is just 5, and 3 squared is 9. So 4/9 minus 5/9 is negative 1/9. There's my answer for cosine of 2x. It equals negative 1/9. And then tangent, conveniently, is sine over cosine. So I take my value I got for sine, negative 4 over root 5, or times root 5 over 9, divided by my value for cosine. And now I hope you multiplying by the reciprocal enough. I would flip this and multiply. What that does, though, essentially is cancel out the 9s when I flip and multiply this by 9 over negative 1, right? The 9s cancel. And the negatives cancel because a negative and negative make positive. So I just end up with 4 root 5 over 1, which is 4 root 5. So there's my answer for tangent of 2x. The pattern on these problems is exactly the same once you get your triangle drawn and figured out. So that really is sort of the pivotal point on these problems, whether you're going to get them right or get them wrong. After that, you're just always plugging them into the formulas and then using your rules about multiplying and adding fractions that you've done for a while now. Another type of problem that you guys will see in class tomorrow is verifying or proving identities using your double angle formulas. So if I'm going to prove something, I'm going to draw my line down from the equal sign and keep the two sides separate. I'm going to start over on this side because I don't really know what I could do here with 4 cosine. Well, I guess I could change secant into 1 over cosine. Might as well do something easy first. And I guess while I'm here, I could get a common denominator. So multiply by cosine of x on top and on bottom. Right? So then I get 4 cosine squared x minus 1 over cosine x. And I guess maybe I could keep trying to go here, but I'm going to stop there for now and come over to this side. If you see something like sine of 3x, you're going to use addition to break that up. So sine of 2x plus x, because 2x plus x is 3x. And then you're going to use your sine addition formula. So I'm going to say that I've got sine 2x times the cosine x plus cosine 2x times sine x all over sine x cosine x. Okay. From here, now I have sine of 2x, so I can use my double angle formula that we learned today. So sine of 2x is 2 cosine x sine x. Still times this cosine x right here. Cosine 2x is cosine squared x minus sine squared x. Ooh, look at me, I'm going across my line. Poor planning on my part, not gonna lie there. Okay. Make sure that when you sub something in for cosine of 2x that you put parentheses, because we are, since there's a minus sign here, gonna have to distribute our sign in. So let's see, 2 cosine sine times cosine, that's going to be 2 cosine squared x times sine x. And here I'm going to get cosine squared x sine x minus sine cubed x. Gosh, this does not look good, does it? I've got a lot of things going on. Can I combine any like terms? Well, it looks like right here I've got a cosine squared sine, and I've got a cosine sine here, cosine squared sine also. So I think I can put these guys together. 2 of them plus 1 of them is 3. So I have 3 cosine squared x sine x. And then since I put these 2 together, then I have minus sine cubed. Oh no, I'm running out of room. Okay. Gosh, but I've got to get to 4 cosine squared minus 1, and I don't see a 4 anywhere in here. I do notice when I look over here that I see a plain cosine on the bottom, and down here I have that plain cosine, but I also have the sine. That makes me think that I need a way to cancel this out, and so I'm going to factor up here. So let's bring this back and up. I wish I had more paper. I'm going to factor a sine of x out. I guess I need to write pretty small to make this work. And then I have 3 cosine squared x. I factored the sine of x out, so that's gone, minus sine squared. So now I can cross my sines out. So I'm getting a little closer, right? I've got the cosines in the bottom, and I have a cosine squared, so that looks good. And now I really need to get rid of the sine squared somehow, and I need it to turn into a 1. So to do that, I'm going to use the Pythagorean identity, where sine squared is equal to 1 minus cosine squared. So I have 3 cosine squared x, subtract cosine squared x from the Pythagorean identity. That negative sine squared is here, all over cosine. And then I distribute the negative, so I get 3 cosine squared x minus 1 plus cosine squared x, since a negative times a negative is a positive. And 3 plus 1 is 4 cosine squared x, which is my right-hand side. So eventually, I got around to proving that they really are equal. Definitely took some tricks in there. Alright guys, that's it for notes tonight. I will see you in class tomorrow. Thanks.